Okay, first we're going to find x. Let's see what we know. Um, we have a theorem, and let's turn to it, which is called the angle bisector theorem. If a point is on the bisector of an angle, and we can see from here that the point J is on the bisector, we know that this ray, or this segment, LJ, is bisecting this angle KLM. How do we know that? Because we get those angle marks that are saying that that's equal to that. So this is bisecting. That means that J, that point, is on the bisector of the angle. And theorem 5.4 says if a point is on the bisector of an angle, then the point is equidistant from the sides. So J is equidistant to K and to M. Okay? So, and the distance, of course, it has to be the perpendicular distance. We go from that point perpendicularly to that side, okay? Which you can see that it does. That's why we need those right angle marks right there, okay? So then we know, due to the angle bisector theorem, that this segment and this segment are equal in length, and so we can then write x plus 5 is equal to 2x minus 7, and just solve it out. Twelve equals x. So we can say up here, x equals 12. jk equals, and we'll find that in a second, by taking the expression for jk, which is x plus 5, and substituting it in. And we get 17. jk equals 17. What does jm equal? You might already be able to guess this. Let's take the expression for jm, which is 2x minus 7, and substitute it in. 24 minus 7 is 17. And the reason you could have guessed that is because they're of equal measure. So if you know one of them, you know the other one. So box that out. That's your answers. Okay, we're going to do the same thing over here for number 17. Find y, and let's examine which angle is being bisected. Well, I'm just going to actually draw on here to show you that it's this angle. And how do we know that it's this angle? Because that's the one that's got those angle marks right there. Okay, and let me use my laser pointer. Those angles right there. That's bisected. So that means then that is the angle bisector, and then the point that we're talking about is point T, which is equidistant here down to VS. And we know that that's the correct distance because it's making a right angle there, it's perpendicular, and down to VU, making that perpendicular. Okay, so what do we know then? Well, we know then that 5y is going to be equal to 3y plus 6. And when we solve this out, we find that y is equal to 3.